So yeah, I'll probably give it another, I don't know, 5 minutes or so and we'll get started. I'm just going to be kind of, I haven't really given a whole lot of thought to how this like little doc's going to be designed yet, so I'll just kind of brainstorm. Basically, there's like two main routes, either do FlexATX or do the internal AC/DC, which I think I'll have to do, which you'll see why. Maybe not this episode, but next episode I'll show why it'll be necessary to do the AC/DC. But for now, I just kind of want to kind of rough out the layout and see what options we have. Surely there's a way of doing it that's way smaller than any of the other GPU docks, so that's what I want to figure out. One thing I'll do real quick this episode is remodel my HD Plex 300 watt AC/DC placeholder model, because let's see, who was it? Oh yeah, Lone. Now, I don't know, it's one thing with HD Plex, it's they iterate very quickly, which is cool, but it makes it a pain trying to plan designs around their future products, because it's like constantly in flux. Because I think within the course of a day, and probably because Lone noticed, and I noticed too, but I didn't think a whole lot of it, is that the mounting holes on the flanges here for the unit, so on, let's see if I scroll up a bit. Yes, I know, always block. So the mounting holes had like 146.4 millimeter spacing, which is different. Is it hdplex.com? Oh, hd-plex.com. That always throws me off. Let's see if we go to specs. Okay, yeah, so it's 144 on the 160 watt, and I believe it is also 144 on the 80 watt. Am I right? Oh, let's see. Spacing. Oh no, it's different actually. Well, that's confusing. That's messy. It's always annoying when you have like different mountings, because it's like really hard to design around that. So anyway, okay, 80 is different, but 160 is, what did I say? 144? Yeah, 144. And then the initial whatever diagram from HD Plex had 146, which is really annoying because it's like it's super close, but like the problem is these are just holes, so the screw would have to go through this hole and then into some kind of thread, and so typically you would have the thread like on the case, like where it would mount into. And the problem is like 144 to 146, that's a difference of 2.4, and really it's like between the two of them, so like each one of them is off like what, 1.2 millimeters off, and then it's assuming it's like you use like an M3 screw, so that's a 3 millimeter diameter screw. So the problem is you can't use the same like you can't have two, it's too close to have two different threads right next to each other, because like they're only 1.2 millimeter difference, but the hole is 3 millimeters in diameter, so that obviously can't work. So it's like, it was really weird that he did that. It seems like a weird oversight, but apparently he's fixed that, because now the updated diagram specs show 144 spacing, which is what it should have been to begin with. So I'll need to check my little model. I'm assuming the rest of the dimensions are probably similar, so hopefully we don't have to do a whole lot there to fix that, but we'll see. It's not a big deal actually, as long as it's just fairly close. We can kind of rough out the model. Let's see, was there anything else? Nope. So I just need this, and then that's the old one already. I don't need this. Alright, well, it's 8:15, so I guess we'll get started. So main thing is, let's see, I need to update this model. or the one I had made. So I made it in Space Claim, so I'll start there and then switch back to SketchUp. It's just, I like Space Claim, but SketchUp is still my preference for what it's actually meant for. Like this type of work, just kind of roughing stuff out. So, but nice thing with Space Claim is it has native import and export, because most CAD programs, if they try to import, I don't know what's going on here. If they try to import a SketchUp file, it doesn't import nicely because SketchUp is a vertex modeler, and CAD programs are typically solid modelers, and they do not cross. But Space Claim, if it will actually open, I don't know what it's doing, actually has native import for SketchUp. So when it like if you model like say a box, just like a cube in SketchUp, like it looks like a cube, right? But then if you delete one of the faces, you realize it's a hollow box. Like it's not, there's no solidness to it at all. It's just basically everything's made out of just like lines and planes and points. So that's the traditional 3D modeler. So like Blender, 3ds Max, Maya, all those are vertex modelers. CAD programs, because they have to deal with physical objects typically, are solid modelers. Like they treat 3D entities as a solid object, which sounds kind of obvious, but like some of the the implication is like if I model a cube in a CAD modeler, like a solid modeler, and then slice it in half, I don't end up with like two half cubes that are hollow. I end up with two like rectangular sections that are still solid, because it's like I cut a solid object in half and now I have two solid objects. So the problem is like most CAD modelers, because SketchUp is a vertex modeler, when you import it, it just gets imported as just vertex points and lines and planes, and it's just a mess. But Space Claim, they've worked with the SketchUp team, so it has native import, and apparently it doesn't want to open. That's lovely. So anyway, so when it does work, it does import it as like a solid, it like converts it to a solid format, so then it actually is usable. There we go. Oh, gotta love it. $3,000 software. Okay. So here is my model. And if you guys want to ask questions in the chat or whatever, feel free to. I have it open on a second monitor so I can keep up. And then let's see. So the spacing is now 144 for the holes, and then overall is 151.4, and then the body of it itself is 136. So let me see. 138. So everything shifted a little bit. Lovely. Okay. I'll just select that and do a move. And then we'll move it to the halfway. And what's 130? I guess that'd be, I can't math. I guess that'd be 69. Is that right? Does that end up with a, wait, 100, what was 136? 136, okay, so I need to move it. Oh, okay. Just goes to show you, just because you spend lots of money on a piece of software doesn't make it any better. It's still buggy. Oh, come on. Really? It doesn't get any better either. Like if you read anything about people who use like $10,000 pieces of CAD programs, they do the same thing. They're just as buggy. Though it's buggy now mostly because I was I probably shouldn't have. I went ahead and modeled like the vents, so then you end up with like a few hundred like little holes, like cylinders there, and it does not necessarily like that. So I may, oh come on, I may just delete them because this is ridiculous. one thing Space Claim is really bad at is vent patterns. Oh, why is it 72 now? Oh. Oh, come on. I wonder if the encoding is putting a load. No, not really. Okay. Let me just delete these because this is getting silly. Delete. Okay. Now let's try this again. Move. I think part of it may be these mirror planes. May have to delete one of them. Come on. Okay, don't need. Okay, normally it's not nearly this bad. I don't know what happened. Usually I don't have much trouble using this. I'm not sure if maybe the OBS is messing with it. I don't know. But let's see. Let's delete this mirror plane if I can. Oh, hey, John. Oh, yeah, they do. Well, huh. Let me, let me turn that off. Let's see. I don't know. I don't know where it's setting. Ah, there it is. No, that's not it. Ah, notification settings. Haha. Bam. All right. You just had to chat in the YouTube chat like a plebeian. Okay. Let's see. Where was I? Oh yeah. Let's see. Delete this plane. Okay. Hopefully it's a little more stable. All right. Or not. Whatever. We'll just get this over with so we can get back into SketchUp. Okay. So we need to move this. We need to move it 68. So that will put us at 136 for the overall length right here. And then, or the length of the body. And then it'll be 151.4 for the mounting ears. So let's just check. Oops. Check. Okay, I really don't know why it's so laggy. It's not usually this bad, so I'm thinking maybe running OBS has something to do with it. 151.4. Well, that's convenient. I bet he did the exact same thing. I bet he just lengthened or shortened the whole model just by that difference to make the mounting holes line up with the 160 watt. So, okay, so we're covered there. And then also, more than likely, the, oh, come on. The mounting holes should be at 144. Sorry, Space Claim's so buggy, guys. I don't know what the deal is. It's not usually this bad. Oh, come on. Because I mean, I had no problems like this when I was making this model. The only real difference now is I'm streaming. Okay, 144, good. So we'll just quickly export this. There's all my little CAD models, but we want to put this under, where do I want to put this? Oh yeah, I do want to put this there. Save. Oh no, actually I do need to fix one more thing. According to loan, because like in the if you look here, so this, because like the way well, actually you won't be able to tell on that. So like the way, because you can tell like there's like countersunk holes here, and then there's this vented plate here, right? So like the way this view shows it is there's this plate mounted presumably like on top of the unit. So it's like a U channel extrusion. So it's just extruded aluminum, which that's a really cool process. If you guys have never seen like aluminum extrusions, it's really cool how that works. And then it looks like this plate's mounted on top right here to cover it, and then it's got the vent holes, and so like the guts of the power supply are just in the cavity in the U in extrusion. But like this view here appears to only be of the extrusion. It doesn't seem to be including the plate, and so that shows 41 millimeters. But Lone here, whoops, I guess I closed the tab, said that the 41 includes that. So I'm not sure whether like this dimension is wrong and like it's 41 and it should come out to like right here, or I'm not sure what the deal is, but he said it's 41. So oh, come on, we'll just take his word for it. And as soon as Space Claim quits being stupid, I will try to fix it. There we go. Okay, I don't know what the deal is. Come on, you can do it. There we go. Man, this should take in like 2 minutes normally. Okay, the reference point 41. So this is one thing I really like. Well, it's not just a Space Claim thing. It's just kind of like working in real CAD, is that you have very precise control over like dimensions, like how much you move it and like what reference point you're using, both from like where you're measuring from and where you're measuring to. Like you just don't get any of that in SketchUp. And so after using Space Claim for a while, I feel so like imprecise in SketchUp because I can't like move things with as much precision as I'm used to now in Space Claim. So it gets rather frustrating for any detail work, which is why I don't use it for any detail work anymore. I just use, oh, come on. I just use it for just like real rough, simple stuff. Okay, so I think we can get out of Space Claim since it's being temperamental. Close, please close. Whatever. We'll open up SketchUp. Good old SketchUp. Okay, let's see here. So I'll just start a new model. Oh, we're already in a new model. Duh. And then I need to... Oh, I bet I forgot to save it as a SketchUp file, didn't I? Probably just saved it as... Yeah, I did. Okay. Not quite done here. SketchUp. Save. Yes. Did it finish already? Documents. What's it? References, CAD models, James, HD Plex, 300 watt. Okay. Actually, yep, there it is. We'll just copy it to a new model. Okay, so there it is. So that's our very basic, just kind of reference model. And then what I shall do, I need to import the... Oh, okay, well, whatever. References, CAD models, James, the HD. Actually, no, this shouldn't be in this folder because I did not import this. This was in, or I did not model this one. This was modeled by QNX in the forum. It's posted in our resources section. So this is kind of like the problem with importing and exporting to SketchUp from other CAD programs, is you end up with this. Whereas Space Claim is much better about cleaning this stuff up because it knows how to talk to SketchUp natively. So anyway, though, so we got our 300 watt AC/DC unit, and this isn't completely accurate because the connectors have been repositioned on the 300 watt AC or DC ATX. but mostly we're just kind of interested in like the overall dimensions. So I'm not too worried about that. So we have that. What else? We need a video card, of course. It's an eGPU dock. What good is an eGPU dock without a video card? So we'll import, I believe this is Subtech. He's also got these. This model's also on the resources section. So these are very accurate models. Like they're very simplified, obviously. Like they don't have any like the details like of like real motherboards and video cards do, but it has all the important dimensions, and it's actually nice that it's simplified because it makes it a lot easier to reference dimensions off of it. And then it also just, it's lighter weight, so it's a lot easier if you have like a bunch of stuff going on in your model. Like you won't have like unnecessarily detailed reference models bogging it down. Like kind of like this is really just, that's a little overkill just for reference, but whatever. Okay, so we can get rid of the motherboards since we're not going to need them, and we shall get rid of the low profile, the single slot, and the other single slot. So we'll just leave like the half length card, the dual slot half length, the dual slot full length, and we may have to adjust the lengths to match up to real world cards. But for now, we'll just kind of leave the both of them in there as they are. And let's see, the Thunderbolt car PCB. I mean, I don't have a model of it yet because I don't have it, so I can't measure it. But what we may do is, it's kind of hard to work if we don't at least have like a very rough idea of how big it is. So let's go to the forum, and then where was it? It was under custom projects, eGPU dock, and let's see, where was it? There it is. Okay, this will be interesting. Oh. Okay, we can use this picture. So let's just save that, download, sure, why not? And then go back to SketchUp, and then we'll open a new instance of SketchUp. What it is, I need to pull out the, actually, no, I don't want to do this in SketchUp. I want to do this in Photoshop. Go to Downloads, edit that. Which, that's a registry trick, by the way. I'd have to look it up. But you can modify the registry to have Photoshop as the default editor for pictures, or like JPEGs, and then you can set it for like PNGs or whatever. Or actually, I think you may be able to just set it for pictures in general. And then what it is, like when you go to right-click edit, I think by default it wants to go to Paint, which is useless. So if you have Photoshop or any other like editing program that's actually good, you can go in the registry and change the default. So then that way, if you can right-click edit a picture, and it'll just go right to your preferred program. But anyway, so the thing with doing what I'm about to do is I'm going to try to tease out the rough dimensions of this circuit board just from this picture. So the thing with doing that is you have to have at least one component or one element in the image that's within the same plane that you know the dimensions of. In this case, we know what the dimensions are of this Minifit Junior, this Molex Minifit Junior 6-pin connector, because it's what's used on video cards. And of course, the simplified model is too simplified and does not have it. So I don't know what it is offhand, so we shall go Minifit Junior. We shall go to the Molex site and check. So for those who don't know, what is this? Download. Okay, I don't know what that's about. Cancel, always block. The power connectors for like motherboards and video cards and stuff are made by Molex. So most people think Molex, they think that 4-pin connector. But what it is, Molex is a company that makes lots and lots and lots and lots of different connectors. So like, even though we usually call the 4-pin power connector Molex, that's really not very, it's bad practice really, because like Molex properly refers to the company, and this particular company, and they make lots of connectors, including the MiniFit Junior Power Series, which is like I said, what you typically use. Your 24-pin, 4-pin, 8-pin, both CPU and GPU are part of this series, which they come in different keys. So, little side lesson aside, let's see here. So we need doesn't matter what series, we just need a 6-circuit connector. Doesn't really matter which one, we just need the dimensions off it. Or actually, no, we want it off the receptacle, or whoops, dang it. The only thing, their website's horrible to navigate, so, okay, so there's what's causing it. We want the plug, is what we want. And it should be close enough. Okay, so 6 circuits, doesn't matter which one, we just need the drawing. There it is, PDF. Okay. This is for an 8 circuit, of course. How useless. Okay, well that wasn't very helpful. Maybe this. That's not helpful either. Okay, whatever, I agree. We do a step file, save. Show in file manager, extract. Okay, so we will be going back to Space Claim one more time. Hopefully it will be less buggy. Okay, there we go. Oh, it is buggy. Okay, let's just try to measure this real quick and get out of here. So, okay, about 14 millimeters. So now, if I go to Image, Analysis, Set Measurement Scale, and then Custom. So if I zoom, okay. So if I just kind of measure this, and so that's 19 pixels, and then I'll tell it I want it to be 14. It has this thing for logical units, so you can say like I want it to be 14 millimeters instead of like 14 meters or something. I don't know where that's actually used, so I don't know if that actually does anything, but whatever. So then if I go to the eyedropper and hold down and go to ruler, and then I want to tell it to use the measurement scale I just set. So now if I measure the same distance, you'll see L1, 14. So what it is like, this is measuring as 14. Like I said, though, it doesn't actually put the millimeter there, so whatever. But what it is now like this, so I know that's a known measurement, and so now if I measure like this, so that is about 166, 167-ish millimeters width. So now if I go back to SketchUp, and I'll just draw probably vertically 1, 6, we'll say 7, and I think default's millimeters. Let's double check. Yep, default's millimeters. Okay, and then go back to Photoshop, and it's hard to tell, this little lip here's in the way, so we'll kind of have to guesstimate it. We'll say probably around here-ish, and go up to match. Or wait, did I measure that wrong? Oh yeah, I got it backwards. Okay, so I should have done the depth earlier. So, but anyway, so 126 for this dimension. So we can just rotate it later, not a big deal. 126, and just make a rectangle out of it. Oops. We'll give it, I don't know, 2 millimeter depth, just so it's like not a infinitely flat piece of paper. We'll just make it a group to keep it all together. And then, okay, so let's say the video card connector, the end of it will be roughly, I don't know, about 10, 12-ish away from the edge. So what I'll do let's see, let me rotate this real quick and then open it up, and then we'll just put like a little reference line. I don't know, what was it? No, we'll do a tape measure line. And what did I say, 12? Okay. So what it is like this, whoops. Okay, right here. So this line should be about the same height as this reference line. So that'll kind of tell us where that goes in relation to the circuit board. And then the video card will basically be flush with the end of it. So we don't have to really worry about the reference point on that because it'll be almost the same. And then I guess just one thing while I'm looking at this. So, okay, so I know what this is, and so thus I can kind of roughly extrapolate what this is. The thing with doing that is that your known dimension, so the known dimension is only accurate within the same plane and within the same, like, depending on perspective. So for instance, this is a straight on, so I don't have to worry too much about perspective, at least in this short area. But I mean, you can notice like, so you can see like there's an angle here at the top left and top right and bottom left, or bottom right, bottom left. And so like they're kind of going outwards. So there's like a little bit of like, there's perspective lines here. You can imagine like this going out to infinity. And so there'd be a line here, so at an angle. So the thing is so in this plane where I know this is 14, this is basically in the same plane. So I can be fairly confident like this measurement here is roughly accurate. But the problem is like you can see there's like a little bit of perspective here. So then if I tried to measure like say this edge of the case right here, like that would no longer be inaccurate. So that's like 434.35 millimeters is what I'm measuring, but that can't be trusted because that is not in the same plane as what I was referencing. So just a little thing, something to keep in mind. Because like if I tried to just measure this using that reference point for the 6-pin power connector, it would not be accurate. Also, and well, this isn't a good one to show it, but like same thing, if this was taken at an angle, then that gets really complicated, which actually SketchUp has a good tool if it's at like an angle and it's a kind of a clear shot, but I won't go into that. So that aside, we got the kind of rough measurements. So let's just go back, close that extra one. Okay. All right. So I think we have all our parts. We got video cards. We got a very, very rough placeholder, but really that's all you need for this kind of thinking. And then we got our power. And what do we need? Oh yeah, FlexATX. So I do not recall what the dimensions of FlexATX are off the top of my head, so we'll go to the handy dandy wiki, go to FlexATX, and they're 81.5 by 40.5 by normally 150. 81.5, 40.5. Okay, so we shall draw a rectangle. What was it? 81.5. Whoops. Comma 40.5, and then extrude that out to 150 and make that a group. So there is our very rough FlexATX placeholder, but really that's all you need as long as you like know what it really is. So like I'm kind of keeping in mind that there should be like a C14 inlet right there, and then that there would be like wires coming out the end of this, and there would be like a fan here and then maybe a fan there depending on the configuration. So like it's, I mean, it doesn't look like much, it's just like a box, but it's just mainly I only need it for the dimensions. I'm kind of just like keeping in mind what the actual like other detail is rather than having it modeled, because like I don't know, that's just the way I work, is I can keep that in mind, so I don't really need all like super detailed models at this stage of the game. Okay, so now we have all our parts. So now we just kind of need to start mocking up how they will all fit together. And let's see, let me just turn these around because I like everything kind of lining up to the axes. Put that over here. Move our circuit board because it'll kind of be the base, and get the power supplies out of the way, and we'll come back to those. And right now, okay, there we go. So now, okay, we can kind of see already that a short video card is going to be supported by default, just because like the case can't be any smaller than the Thunderbolt card or circuit board. And the circuit board is actually fairly large now that I see it in context. So okay, so definitely short cards will not be a problem supporting, because we have to if we're going to fit the card inside the casing. So now it's just a question of like how much bigger a card do we want to support. And then one of the things I had mentioned in the thread was I was thinking, let me get this at the right height, I guess, for the both of these. Let me go back. So I'm going to move, like I said, so the edge, the bottom of the slot connector should be roughly at that height, kind of extrapolating from the model. It's nowhere near exact, but we just need really rough measurements at this point. So, and then there'll be a little gap between them. I'm not sure how much, so we'll just kind of guess. And then let me just hide that for now and get it out of the way. Okay, so this is kind of like the minimum, like the minimum we have to account for. Like if we use like an external PSU, for instance. So, and one of the things, like I was saying, one of the things I had kind of, and it's something I've been thinking about and I mentioned in the forum thread, was doing something like this, having the AC/DC unit like kind of in the front. And so what it is like, you could use, okay, yeah, if you used a short video card, you could have the internal AC/DC unit, and then that'd be kind of like that'd be like the preferred, like the default arrangement. But like for instance, like if you wanted to use a longer video card, rather than making the case longer and then just like having wasted space for people who actually use like an SFF video card, so I was thinking we could do this. And then if you want a longer card, you could just not have an internal power supply. You'd be limited to an external brick, and then you could have like your longer power supply. It'd come like take up the difference. So that's one thing I was thinking of. And then the only issue with that is, where do we put the HD Plex, the DC-ATX unit? Which, what it is like, so this is kind of like the reference height for the video card, which we all know rarely do video cards actually ever end up at that. They're almost always like taller. So either like the heatsink's taller, or the shroud's taller, or both, or the worst one's when the video connector is not recessed, so it's like ends up here, which doesn't seem that bad, but then you had to realize you had to have room for the cables, so then you end up here. So what we can do, we can shift this up a little bit, because we know we're going to need that space anyway, and then we can maybe put the DC-ATX unit underneath, maybe something like that. Kind of shift it over a little bit, something like that. Connectors, well, same thing though. We had to take into account the connectors, because you're going to need at least 15, preferably 20 to 25 millimeters space for the connector, and then the wiring coming out of it. So let's see if we shift this over. Oh, that kind of fits nicely into that little gap. So yeah, we could probably move that up closer to the video card, really. So that could work. Yeah, the new 300 watts quite a bit wider, so we may want to turn this. Oh yeah, yeah, that would work. It's all kind of constrained with, so we don't have any one component just sticking out a lot further than the other and kind of driving the dimensions. So that's rather convenient. So we can all have everything kind of within the same, roughly the same width. The one thing here you can see there's perspective here because that's the default setting in SketchUp. I'm going to turn it, well, normally I'm used to working in parallel projection. So what it is like basically there's no perspective. Like if you look at something straight on, it's straight on, whether it's really close or really far. And so like, yeah, so what it is like, so these are two parallel lines. Like they are in reality, like in perspective mode though, you can see they're like they're converging towards a horizon point. So they're not parallel as it's rendered here. Parallel projection does away with that. So it's more convenient because then like everything's like straight angles and it's easier to tell if stuff's lined up. It looks very unnatural though if you're not used to it. I've gotten used to it from working in like space claims since it's an actual CAD, but I guess I'll leave it off for now because it does make, because it's a very unnatural way of looking at things like objects and scenery and stuff, it makes some people like almost sick, like kind of like a motion sickness type of thing. It's like unsettling to them because it's an unnatural. Like the real world always has perspective because that's just how physics, the way light works and stuff. So I'll go ahead and leave it on. But so yeah, everything does line up though. So that kind of tells us this. We'll definitely need to do more work, but this is kind of like a minimum size. So let's just kind of rough out how big of a box we're talking about. So this is one thing where having parallel projection would be handy. I think that's about right. Whatever. Oh no. Okay, move that down a bit. Okay, we'll just extrude this up, cover everything. And let's see, move this over a bit. This is what I'm saying, like I'm used to Space Claim now where I have very good precision over stuff like that. Okay, so I guess this kind of like, this would be like the minimum size box we would be looking at. And as far as that goes, we are looking at what? Let's see, we'll do width. Oops. There we go. Okay, let me get out the calculator. And so we're looking at around 241 millimeters in depth times, let's say 183 millimeters in height times, let's say 60 millimeters in width. So the really cool thing with metric, because metric is awesome and it actually makes sense, is that if we take the dimensions in millimeters, so multiply them together, we'll get cubic millimeters. And what it is if we move the decimal place over 6 times to the left, that will give us the volume in liters. Oh, yeah, that is true, like in SketchUp in particular. But I'm just going through this because, was it Wugtug in the chat is saying that I could just go to SketchUp and get this information. And that is very true. Yes, that is correct in SketchUp. I'm just saying this because, like, in general, like Silverstone puts liter, like volume in liter on their specs for their cases. But like most other manufacturers don't prioritize like what the volume of the case is because they're most, like Silverstone's very much heavily invested in SFF. Like Corsair, like I've yet to see them actually develop anything that's SFF. Like Bulldog is a joke. So anyway, so I'm just going through this like just in general. So like in general, you're looking at a case, you see all the dimensions in millimeters. It's like, oh, well, like what is that in liters? So like you can take the dimensions, the 3 dimensions in millimeters, multiply them together. You'll get the volume in cubic millimeters, which isn't particularly a useful number. It's just like cubic millimeters. Like most people don't have a reference point for like how big or small something is when you tell them how much it is in cubic millimeters. But that's the cool thing with metric is I can just move the decimal place 6 times to the left. And the nice thing is when you're talking computer components, most things are in the like 1 to 10 to 20 liter range. So typically it's just like the millionth. So it's like 2.6 million would be cubic meters, I think, or something like, no, not cubic meters, cubic decimeters. I don't know. Anyway, move it over 6 places to the left, the decimal point, and then you end up with the liters. Just long story short. So we're talking less than 3 liters for this design. Just doing it manually. But then, yeah, like Gub is saying, if I, let's see. Whoops. Oh, I'm still in dimensioning mode. So let me get rid of those. And then if I make this a group and then I go to right click on it, go to entity info, and oh, well, I would still need to like figure up like how many decimal point or decimal places to move it over or whatever, because it just gives it in millimeters cubed. So I would still need to like kind of mentally figure that up in liters. But yeah, so you can do it that way in like SketchUp, and a lot of other CAD 3D modeling programs will be able to do it for you. But anyway, so 3 liters. So let me see if I can just delete this, because really I just wanted to kind of extrapolate the dimensions. So 3 liters, that's pretty small. I guess just for reference, so of course, like, it's like the proportions are a lot different, but 3 liters is basically like a really big ATX power supply is about 3 liters. So just kind of give you like a reference point. So for the size of a really big ATX power supply, we could fit a GPU dock, an external GPU dock. And of course, that's like best case scenario. In reality, we'll have to account for like bend radius and stuff like that. So the size will probably increase depending on how we design the frame. Oh yeah. So yeah, Troy's here. So he's the one funding it. So give a hand to Troy. Or also he's Run Amok 81 on the forum. So he's got a Keto. Was it not the Node, because they're out of stock until like mid-February. I think it's the Thunder 3 box. So he has that in order, and he'll be shipping it to me, and I shall measure it so we can get a more accurate, dimensions for the actual PCB, other than just this little rectangle here. But anyway, so let's see. We're looking at what for this kind of hypothetical design. We're looking at 163 millimeters or so length for the video card. Not very much, so that's pretty short. But like I was saying, if we do go with this type of design where it's like kind of a multi-purpose AC/DC unit where you can have it and have it internal, or you can not have it and have a longer video card, so then that would give us, for instance, about 240 millimeters. So that's pretty good, actually. That would cover a lot, like 160, 170. That's going to really limit your choice of video cards. Whereas 240, 250-ish, you'll have quite a few options once you get into that range. And I'm still not good on all my dimensions, because video cards are still mostly advertised in inches, so I'm still don't have all the different kind of common sizes memorized. So 10.5 is about 270. So we're really close to kind of your standard NVIDIA reference card length doing that. So 270. 270. We're already at 235. Another 40 millimeters. That's tough. That's really tough, because it's one of those things, is like, it's only 40 more millimeters, but it's like, well, yeah, but then it's like, well, another 20 millimeters and you can support this or that card, and then another 10 or 20 millimeters in height and we can support this or that card. And so that gets really tough. It's like you have to draw the line somewhere. But 10.5 is pretty tempting, because that opens up a lot more video card options. That will be a toughie. I'll have to think about that. The problem is like where we're at now is kind of like, if you do use a, well, actually, because this is assuming like a pure like reference half-length card, which most of them actually aren't. So let's do some quick checking. Let's say, I don't know, the EVGA 1060. How long was that? The SC. So their dimensions are nowhere near accurate. I talked to Jacob at EVGA about this. I don't know if they ever fixed it. 172. I'm pretty sure that's optimistically short. Oh, I can't remember. Okay, we'll do that trick again. So if we, there it is, save image as. We'll just open that in Photoshop. Edit. Okay, if we go to image analysis, set measurement scale, custom, we know this dimension right here is roughly 86-ish, 85-ish millimeters or so. And then make sure set reference scale, and we come up with a more like 100. Of course, there's like perspective here, so it's a little hard to say exactly. More like 190, 185, 190. So definitely the what was it? What did they say? 172. Yeah, that's laughably incorrect. So that's okay. So that's one card. That's the EVGA 1060. And then if we look at the Zotac, let's say the 1070, because we really don't know exactly what the 1080 is yet. So hopefully Drew, that's 3 Elf King on the forum, he will be at CES officially representing SFF Network, and he is bringing along a pair of calipers. So anything that's questionable, he's just going to go there and measure it. So we don't have to put up with this nonsense. Manufacturer specs, man. Okay, so they say 210. Okay, so that's longer. So 210. And then the EVGA was like 10, or what did it say? 210? Or no, 190. And then this is about 160 as it is. A 1060 would be a really good card. It would suck to have to do an external brick just for a 1060. Let's see. So if we move this 50 millimeters, that gives us about 220. And then without the brick, we'd have what? 285. So this is kind of the problem. Well, no, I guess, because I mean, it looks like there's a lot of wasted space if you have a short card, but then you had to keep in mind like cards that are actually this short, like 170 to like 150 to 170 millimeters. That would be that'd be pretty rare. So that would be like something like the Nano or some of the 1050s. 1050. Then again, like a 1050 would be a weird card to use for an external GPU dock because it's not very powerful. Because one of the, like, to me, one of the big things with the GPU dock is that you could have like a fairly beefy card, and then you could have like a fairly, like an Ultrabook, for instance, that has a good CPU but like really no graphics horsepower. And then like when you're home and you want to play games and you're not having to run off battery, you could plug it all in. And then you would probably want a fairly beefy GPU if you're going to have that kind of setup, because if you're only going to have a 1050 in your dock, I mean, you could buy a laptop that still has good battery life with a 1050 in it. So like, yeah, I guess it would make much more sense. So yeah, it wouldn't really make sense to design around like a 170 millimeter or less video card. So we'll assume most people would want something in the 190 to 220 range. So if we do that, and I think that's what I have modeled here right now, yeah, 220. So then that would cover most of like your kind of more like mid-range, maybe high-end SFF type of cards. And then if you do want to do like a reference NVIDIA card or like a non-SFF card up to 285. So that would cover basically all your 10.5-inch class video cards. So that would be like your reference like 980 or like 1080, reference 1080, reference Titan, or well, all the Titans are references, but yeah. Oh yeah, so Troy, as far as the Nano goes, the problem with the Nano is it's very spiky. And that's a lot of like, most modern video cards are spiky because that's how they do power management, is that they average much lower than previous generations, but they're averaging lower. So the way they're really consuming less power on average is that they consume just as much power as like previous gen. At least this was more of the case with like the 900 versus the 700 series, for instance. The 10 or the 1000 series is on a new process node, so they do get more power efficiency off of that. But like the 900 was much more power efficient than the 700 series, even though it was built at the same process node. And a lot of that is that they would be able to like really quickly spike up in power, render out what it needs to, drop back down, and then just ramp up, ramp down, ramp up like very quickly. And so it would average out at a lower power draw, but like the very peak could be just as high as the 700 series. And so the Nano is like that, but even more. Like it spikes really badly. So on average, its power consumption is not that bad, but it's very, very spiky. So for like, and we're talking like really short amounts of time, it will spike up very high. The thing is like ATX power supplies, like part of the ATX spec is that they can handle that type of thing. So like this never really became a problem. Like if you have it hooked up to like a normal ATX or SFX or whatever power supply, the problem is if you try running a Nano off a ACD, like a laptop adapter, like a big laptop brick, because they're designed to power laptops, obviously, and laptops have batteries in them that can absorb that type of spike, and then to begin with, the laptop hardware doesn't really spike like that anyway. So the issue with the Nano is that it would spike, and then the AC adapter, like the laptop brick, couldn't take it, and the unit would shut down or just be unstable. The thing is I don't know if the HD Plex will be susceptible to that. It's only 300 watts, which is really beefy for an internal AC/DC unit, but it's still not a ton. So I don't think it has enough overhead to handle the Nano. I don't have a Nano. I don't know anybody who has one, so we won't really know until somebody tries. I think Larry at HD Plex has tested it with the 970, and he knows for sure that's perfectly stable for several hours. But the Nano, we're not sure. And the Nano's neat, but I mean, it's kind of an oddball, so really I don't see much point designing around it because it's going to quickly get outclassed once HBM2 is out. So I really would rather not design around it, because the concern would be it's a one-off, like they'll never do it again, because it's like, it's a weird card. I mean, for SFF, it's really cool, but for the greater market, it's a weird card. So anyway, it's kind of a bit of a long aside. So back on topic. So I guess we'll just assume most people are going to want something like at least a 1060. For an eGPU dock, it doesn't really make sense to put something in it that's any less than the GTX 1060, or at least a 1050 Ti. And most of those, let's double check. Oh, we're already at the Zotac site, so let's go to, what did I say? 1050 Ti, the mini. So that looks pretty short. Yeah, that's basically like 100 160-ish, something like that, or 145. I don't think it's that short though, but so yeah, 1050 Ti would work, but basically anything else, 1060-ish, 1070, will need the longer dimensions. So SketchUp. So yeah, so I think this would be more practical as far as what kind of cards people actually want to put in it. So it looks like there's a wasted space, but keep in mind, like with the video card that most people would put in here, it would be like right up against it. So this isn't really wasted space. And really I could just, whoops, there we go. Make this, what was that, 166. We'll make it 25 millimeters longer. Now we'll say 30. Okay, so yeah, it doesn't look like so much wasted space now. We'll just get the PCB. Okay. Okay, that looks like fairly good use of space. And then, so like I was saying, is if you don't have the AC/DC unit up front, you'd have about 286 millimeters of space. So that would cover all kind of like your 10.5-inch cards easily. Though it's kind of like the weird situation where, like, if you do want the bigger, longer card and presumably draws more power, then you have to use an external brick, which is limited in the capacities that you can get. So it's kind of a weird situation because this HD Plex will be 300. You can get 330 watt external bricks, though like I'm saying, they don't handle spikes very well. So depending on which card you use, it may actually be a worse solution, even though on paper it's 30 more watts. In reality, it may not handle it as well as the 300 would. But then you could always get one of those Meanwell monsters that can just like do ridiculous amounts of wattage. Let's see, 19 volt. Yeah, like one of these type of things. So, oh, that's 24 volt. Input. Oh yeah, that's definitely something for a server. But something like that with lots of wattage. So anyway, the only thing I don't like about this is that then you end up with this wasted space here, like in front of the DC-ATX unit. There's not a whole lot we can do with it. Like one thing is like using it for like say 2.5-inch drives, but then the problem is like how do you hook that up? Because like basically this is just a real simple project, like a custom circuit board to be able to integrate like say the Thunderbolt 3 stuff and then like 2.5-inch drives. That's out of the question. We just have to kind of basically cobble it together off of the Akitio since it's readily available. But just for kicks, let's import, if I can remember where I put it, there it is, 2.5-inch reference model. So same thing, just a real basic model just to give me an idea of the dimensions. And it is way too wide. Oh yeah, way too wide. So yeah, I don't know what we're gonna do with that space. Oh yeah, cooling fan. Yeah, that's true. I guess you'd be limited to like what, a 40 mil fan? Oops, 40. Because there's really not any good justification to make this like wide enough for a 60 mil. Because I mean, I guess I didn't take into account earlier that this circuit board is going to need standoffs to space it off from the sheet metal so it doesn't short out something on the back side. But even then, I don't know what it would require. I could probably just measure what it is in the current housing, but at least with ATX based motherboards, it's 6.35, which is a 1/4 inch. Computer part specs are kind of funny. Like older specs were designed using just like customary units, like standard American units, and then like later specs were done with metrics. So it's kind of, sometimes you end up with weird mix of dimensions. But even if we have like 5 millimeter spacing, so the video card's not pressed up right against the metal, and then 5 or like 6 to 8 standoff going the other way. Yeah, we still wouldn't end up with enough room for a 60 mil fan, so we'll be limited to 40. So, and we have about what? 120. I guess you could put 3 40 mil fans in this space if you wanted. That would be a little silly, but I guess you could. Huh. But the problem is really, there's really nothing else you could do with that space. It's too narrow for a video card unless we want to make the housing a lot wider. And I don't know. It may just be wasted space, unfortunately, because I don't think we can shift. That's 150. And what did I say this was? This was 120. Oh, hey Brian. How much of a delay is there? Well, I guess you won't know unless without some way of syncing it. But yeah, it seems like there's quite a delay between me talking and the chat, which is kind of annoying. But anyway, yeah, hey Brian. Yeah, I mean, we're not gonna get real. We're not gonna end up with like a finished sheet metal design today or anything. So yeah, we still got stuff to do. So yeah, there's the FlexATX, which now that I'm looking at it, because it really conveniently ends up being that like this solution with the DC ATX and the AC/DC are conveniently not much wider than the video card and then the Thunderbolt PCB. So that kind of ends up being a nice slim package, which is really nice. I really like that is. The problem with FlexATX is it doesn't really fit in if we want to keep it that way. Like if we want to keep it nice and slim. Because obviously it's fairly wide in this dimension. Length's not really a problem because like the video card's going to be much longer than it anyway. So that's not a big deal. The problem is like if we rotate it, so yeah, it's like slim, but then you have all this height. And then like where do you put it? Because if we put it here, then that's just silly. You end up with this like really tall but really narrow dock. So basically you can't stand it up. It's just going to fall over. So you're going to have to put it horizontal, which if that's what you're aiming for, if you purposely want it horizontal, that'd be perfect because it'll be really wide but really short. But I mean, I guess it doesn't have to be. Most docks are designed to be standing up, and I don't know. It just seems kind of like the natural form factor, because it's like presumably it's something you just want to be able to kind of not take up much space on your desk, and you can just hook up your laptop to it. So it kind of it seems more natural for it to stand up. But this would be way too tall. What if it took the place of the HDplex AC/DC? Oh yeah, if we put it like vertical. Oops, come on. There we go. Well, the problem with doing that is that there's cables coming out both ends. So you would need an angled AC cord, which right now is a bit hard to find. And then there's like the wire harness coming out the other end for like your power connectors. And right now sourcing an angled power cord is a bit of a problem. And then you would need about 20 millimeters for that. So that would be there. That'd be okay. and then you would need about 20 to 25. Plus it's wider, like this, like wider in this dimension. It could do, I mean, you could do it for sure. You definitely could, but the case would be deeper, it'd be taller, you'd have to source a internal power cord, and then there'd have to be some place to put that. Probably it had to be like right here underneath the bottom of the video card. Plus the other thing with FlexATX is like the 500 watt platinum rated unit from iFrelix account is pretty quiet under like normal loads, but almost all the other FlexATX are, they have 40 millimeter fans, so like under any kind of load they scream. And at idle, most of them aren't very quiet. The 500 watt platinum is, because I believe it runs semi-fanless actually, if I recall correctly. So of course it's pretty quiet at idle because the fan's off. And then at most mid-range loads it's not too loud because it's able to keep the RPMs under control. But the problem is it's not readily available. So the FlexATX that are loud, and then it makes it bigger. So I don't know. I'm kind of leaning against FlexATX at the moment. I don't know. We'll think about it. I mean, this isn't the only layout. We could do other layouts. And then why do we need such a big DC PSU? A Pico PSU should be able to handle the load pretty well. That is true, because HD Plex does have the new the Pico type unit, which will be 200 watts. That is true. It's 200 watts. That would cover most video cards. Yeah, he'd be upset if I just ditched the FlexATX. But I mean, it is an interesting form factor, and I think it has a lot of potential. But the problem is like for a SFF case, the dimensions of it make a lot of sense. For a dock, they don't really, because none of the dimensions really, it's like it's a little too wide, it's kind of long, it just doesn't really match up well. Because I mean, if we do it like this, like if we don't want to make it too tall, for instance, let's see, move it over a little bit, move it forward, move it down, yeah, something like this. The problem with this is like, yeah, it's not very tall. Like you can get rid of that, you can get rid of that, and then like you can make the height narrow, but you have like all this like wasted space and all this wasted space. So it's just, I don't know, it doesn't match well with video cards is the problem. And I think this is part of why all the like the Razer Core and the Asus and the Power Color and all those docks is like, if you use SFX or if you use FlexATX, like the dimensions and the proportions of those power supplies compared to the video card, which is typically a fairly long but not very wide, it doesn't really, they don't mesh well together if you want to have the overall size of the enclosure fairly small. So I don't know. And then Pico PSU. I don't know. Pico PSU, it would work. It's, I guess, 200-ish watts, which would power most things for sure. That would definitely be 1060, 1070 territory. I can't remember what the 1080 draws offhand. We'll look Tech Power Up because they actually measure power draw from the card. Power consumption, 186. So that'd be pushing it, but I guess you could even do like a reference 1080 off a 200 watt, either the Pico PSU, the Pico PSU that can do the high wattage is the 12 volt version, which is a little harder getting AC/DC adapters that can do that. Because it's only rated for, I think, like 160 or something like that, but it can do much higher than that if you give it a little bit of cooling. The HD Plex one that's coming out can do just 200 watts straight up, and it can take wide range. It's like 19 to 24 volt, I believe. So then you can use like 19 volt adapters. So those are much more readily available in higher wattages. Like you can get like the Dell, and I think HP makes one for the Voodoo, that are like 250, 300, 330 watt ranges. So those are pretty good. Though, like I said, like something really spiky like the Nano, maybe not. But yeah, that's what I'm thinking, Gub, is that like if you're gonna do a dock, you might as well do a high-end card, because you're gonna be like, it will overall still come out cheaper than a Razer Core, but this is going to be still a fairly expensive solution. So you have like $200 or $250, I think $250 for the Kedio Thunder 3 box. So that's let's see, let's add this up. So that's $250 for that. Plus, if we do like the 300 watt AC/DC DC-ATX HDD Plex combo, that's around $150. We'll just say that. And then this enclosure, I have no idea what it's going to cost yet, because it really depends on order quantity and then the complexity of the design, which at this point I'm leaning towards a very simple design. Just I don't have time to design anything real complex. So I don't know. Let's say, I don't know. We'll just say $200, just kind of on the higher end. So $600. Okay, so we are basically at the Razer Core, because the Razer Core has power supply built in. So fairly expensive solution. So presumably somebody spending $600 for kind of a hacked together eGPU dock would want to have like a fairly, so more than likely somebody dumping that kind of money for a hacked together dock has money to spare. So more than likely such a person would put a fairly beefy video card in it. Probably more like a 1070 or 1080 or whatever Vega has to show us. So I don't know. I don't know if I'd want to design purely on a Pico PSU, because that kind of puts an upper limit on power. And I guess you could always like, you could have like a Pico in here also and just chain them together or something crazy. Yeah, the G-Unique stuff looks good, but the thing is, like, I don't think we've announced it yet. No, I don't think so. But we are working on something to make that more available. But even then, I mean, it's really convenient HD Plex. They have warehouses in, I think, Shanghai or Hong Kong, Germany, and then Los Angeles, I think. So it's just much more readily available. Hopefully that'll change a lot for the G-Unique in the next day or two. We'll have an announcement about that on the forum. But yeah, still HD Plex is fairly common, or relatively readily available compared to even what will happen with the G-Uniques after the announcement. And then I know they have the 400 watt or the high wattage one that's like this form factor. Do they have one that's a Pico PSU form factor? I don't recall. Yeah, I don't remember. I don't know the link either. But anyway, like I said though, availability. So I don't know. It just seems to make sense to design for this. I don't know. It's kind of tough though. It really is, because it's like, and this is kind of the thing with designing SFF is like, it's like, which route do you go? Like, I mean, we could definitely make it a lot smaller and just say Pico PSU only, but then it's like, would that be too limiting? Would people want the option of like a HD Plex style unit? It's a really tough trade-off. It's because it's like, where do you draw the line? Yeah, Elf King's thread. I don't know if he has the Pico PSU style ones in the thread though. That's what I was wondering. And I would need to see a picture of it to see what size it is. Where was it? It's under hardware, I think. Why not try to make the unit a bit wider so that the AC/DC can fit at the bottom as well? Oh, well, first things first. Let me see if I can find that unit, and then we'll come back to that. Oh, there it is. List of DC-ATX units. 400 watt. 200 by 100, 186 by 86. I don't think he has the Pico PSU style ones on. Oh yeah, there's those touring middle ones which look interesting, but availability of them seems basically non-existent. I don't know. What's the wattage of this thing? I can't read it. I know. Where's Google Translate? Oh, there it is. 400 watts. I don't know. 400 watts seems really optimistic for this type of unit. I don't know how he's doing that. Huh. Yeah, that would be interesting. But I mean, that kind of comes into the thing is like, I mean, assuming it can do 400 watts, or is that, I don't know. That seems really high for such a unit in this form factor. But even then, it's kind of like the availability thing. Is like, even if it is somewhat available, I don't know if I'd want to rely on it, since they're such unique units. Oops. I don't know. It's kind of tough though, because it's like they're much smaller though. If they can actually do that kind of wattage, and then I could definitely make this a lot smaller. I don't know. It's tough. But anyway, so as far as what was it? A bit wider so they can fit at the bottom. So the problem is like there really isn't room for it unless we make it like twice as wide, which then that's like kind of pointless because we still need the depth here for the video card. So there's really nowhere to put it. Oh, unless we, yeah, if yeah, I mean, if we did do the Pico PSU, we could put the AC/DC down here, and then just put the Pico basically anywhere, since it's not very big. I mean, it's like the thing, and then we're relying on that one unit. Which I guess we're kind of doing the same with the HD Plex, though not quite as bad, because there's the HD Plex 300 watt, and then the G Unique has one in this type of form factor, so then you'd have like two different options. So that wouldn't be quite as bad. I don't know, it's tough. And this is kind of the thing with just SFF design in general, is like you kind of come to crossroads. It's like, well, which route do I go? Because the problem is like, I mean, it's SFF. You can't just do both routes because then it's bigger, which kind of defeats the purpose. So you had to kind of like pick one and optimize to it in order to maximize the volume of space, or to maximize the space usage within the volume you have. I mean, if you're clever, you can kind of have like dual uses. So like that's kind of what's going on here. So you have the video card, and then you can have the external AC/DC and get a longer video card. And so you kind of have two different use cases like within the same amount of space. But then this is kind of a problem because it doesn't really fit nicely in that arrangement. So it's kind of like stuck off to the side and just taking up space. That's tough. It really is. I mean, the G uniques look really cool, and I really hope a lot for them. But I mean, at the end of the day, though, they are, even once we have better availability, which will become more clear once we make that announcement, it's still shipping from China. So there's always that. Let me close this if it'll close. So I don't know. I probably will stick with the HD Plex, like this form factor, just because it's more proven. And then also, like, worst case, I mean, you have 300 watts, or even maybe more with the 400 watt. Because like 400 watt in this form factor, yeah, that makes sense. So the G Unique 400 watt like this, yeah, that's fine. But the Pico PSU one, I don't know. Maybe it's true. I would just have to see it to believe it. And I don't have one, and I don't really have time to mess with that right now. So I think we'll stick with this. And I think we can rule out FlexATX. It just doesn't fit anywhere nicely, and then availability is also a problem. Well, they're available, it's just they're really loud, and the one that's not really loud is not available. So I think we'll just ignore it. Oh, okay. DC and so you mean like having both of them internally? Is that what you're saying? Like having both the DC ATX unit and then the AC/DC both inside the chassis? Is that what you're saying? As opposed to just having an external brick? Man, this delay on chat's really annoying. I think he would agree, though. Like, a GPU dock, if the goal is to make it really small, it just doesn't really fit. It's just the proportions of it just don't really make. I mean, you can see, like, me messing here. It just doesn't really work. Yeah, so as far as, like, this is kind of a personal preference thing. I just despise external bricks. I just really do. I can't stand them. So seeing like some of those ASUS SFF rigs where it has 2 external bricks, that's just stupid. Yeah, I mean Twitch has a delay too. I don't know if it used to be pretty bad. I think they've improved it a lot, so it may be better than this now. So yeah, the next stream may well be on Twitch. I may do some research because like for gaming, it's not so bad because like you're gaming and you're doing stuff, and then like when you're not gaming and like you're dead or something and you're waiting to respawn, you can address chat. For something like this though, where it's more direct, it would be nice to have something that's more less delay between the chat and the stream. So I think I read I think Microsoft has something to do with it. I think it's like they're promoting it for Minecraft. I think this is supposed to have really low delay between chat and stream, but I'll have to do some research on it. But yeah, I thought the YouTube one was a lot better than this, but it's really not. So I'm going to have to do some checking on it because I'm not too happy with how much delay there is between the chat and the stream so far. So yeah, maybe Twitch next time. We'll see. Discord and YouTube. Discord for chat. I mean, yeah, and that's what we do for the podcast, actually. And I probably should have done it for this, which I could do that. Let me spin up a Discord room real quick, and we can maybe move there, not have to put up with the delay. Oops. Let's see here. Sorry about that. I didn't know what would show up if I opened it. No, I want it open on this window. I don't think there's anything important it would show. Yeah, streamer problems, man. It's just I'm security conscious, and it always bugs me when I see streamers like they open up something and then there's like sensitive information in the stream. It's like you're an idiot, or at least you're just not careful enough. Where is Discord? Let's see. This is more trouble than it's worth. Yeah, whatever. I don't think it'll be anything too big a deal. Yeah, that's the thing, is like you have Discord going and then the YouTube going. It's kind of a pain. Oh, actually, that's why I have Vivaldi open, because I don't use it normally. So there's nothing in here. So, ha. And what happened to my Discord? Oh, there it is. Where did it go? There we go. Move that over here. Yeah, that's nothing interesting. Voice channels. Let's see. I will need to make... Geez, how do I want to do that? Because the audio and the chat would be in sync, but then the video would be off. Because there's one thing in the podcast, because we're mostly talking, but this is more visual. Yeah. That is getting kind of messy. And then it's like, we could have audio and chat synced up perfectly in Discord. But then like what about video? Like, how far is that off? Or we could have video and chat. I guess with YouTube, it's basically both the video and the audio is way off chat. And then with Discord, at least the audio is in sync and the video is off. But then you're signing into something else. Yeah, we won't worry about that for now. I don't want to get that set up right now, because we're not going to go too much longer because I have other stuff to do. So yeah, chat I'll have to figure out. So actually, I'm really not much into streaming. I don't really watch much of it, and this is my first time doing it. So if you want to give me suggestions in the thread or something, then feel free to. For now, we will soldier on. So I think we shall settle on this for the basic layout, because I can't think of anything that would be better without just going anything really crazy. Because like I said, we get dual use for the AC/DC. This is kind of messy, because if we did do Pico PSU, it'd be we could eliminate like kind of like this space right here. But then it's like, what about the availability of those? So we'll just do worst case, because I mean, even if we do switch at later, depending on the frame design, we could just like reduce the height of it, so then it wouldn't be a big deal to switch that later. So now let me just kind of think how I want to do the frame design real quick, and then we'll sign off for the day. Because the simplest one would be a two-piece design. So let me see if I can get Space Claim to behave for 2 minutes. Okay, let's see. Go back to Documents, My Projects, Smallest ATX, and I think Rev 3 was the last one. Go to Space Claim. But yeah, if you guys want to give me suggestions for what to do for streaming, what I may do is I may make a new thread in the off-topic section so I don't clutter up the eGPU thread. Just like, I don't know, streaming discussion or something like that, and we can chat about it on the forum between now and the next stream, which I'm not sure how I'm going to do this, if I want to make this like a regular scheduled thing, like every Wednesday. And I'd like to do that, but it's like I have other stuff to do, and this isn't like super high priority. So it may just be like whenever I can. So there may be kind of like short notice, but that's kind of inconvenient for you guys who want to watch live. So I don't know, we'll see. So anyway, all right. So here, nope, it's still not acting nice. So I think Space Claim does not like when this OBS is running, because it just gets super weird. It's not normally like this, so I think OBS is messing it up. So, because it's fairly CPU heavy since it is a CAD program, and I am encoding on CPU right now. Because I thought it's a 6-core. I thought it could handle this without any problems, but maybe not. Okay. So, the cover... Oh, come on. It's not working. I don't have a SketchUp of it exported right now. I'm going to do this. Whatever. We'll just model it from scratch. So, easiest way to do this would be... Let's see. We would want a 2-frame design... Because there'll be standoffs for the Thunderbolt card. And generally what you want to do if you're trying to design a simple frame is you want all the dimension, like all the dimensions that have to be good, like have to be accurate in relation to each other. You want all those on a single piece of metal. Because then that way the laser cutting or the water cutting, Kerbals, yeah, I got it's a really cool wallpaper. I think I posted it in the wallpaper thread on the forum, by the way, if you want to check that out. Yeah, you want the because there are going to be standoffs for this circuit board. And so those will need to be precise in relation to the video card because the slot on the circuit board is attached to it. So like so then the dimension or like the position of like say the standoff and the cutouts for the video card will need to be accurate in relation to the position of the standoffs for the circuit board because they're going to be like the video card has to be able to plug into the circuit board. So generally we would want that on a single piece of metal because then you just have the one bend and then that will have some variance in it, which that's just unavoidable, but it's better than having two different pieces because then you have the variance of the individual pieces and then the variance of the attachment method, which if you use screws or whatever, it may not align perfectly, stuff like that. I mean, there's definitely ways around that, but it's just, this is a real simple project. So we would probably want this as a single piece of metal. And then if we're going to do that, so that would be that. And generally you would want to do a U-frame. So that would be like a U-frame like this, or like, I guess more accurately like this. So you'd have it like here and then bend and then bend. So that's a U-frame because it's shaped like a U. How imaginative. And then that would be that. So let me just model it out real quick. Let's see here. Something like that. Oop, too far. Yeah. Yep, see ya. And let's see, do something like this. Oops. Something went wrong there. Let's try to copy it. Okay, there we go. Let's see. So something like that would be like the base frame. So that's what I was saying is so like the standoffs for the circuit board there would be here or however they're arranged, and then the cutoffs and the standoffs or the retention flange for the video card would be there, and they'd be like they should be fairly accurate with relation to each other. And then if you're going to do this, you might as well do this half here, because then the thing is if we do it this way, then we just need one other piece. So like just another U piece, just going the other way, from here to here to here. So then that gets you full coverage, so you have a complete unit with two pieces of metal. And with sheet metal work, the less pieces, the cheaper, generally, like to a degree, unless you have just like one super complicated piece rather than having like 3 really simple pieces that are just attached to each other. But generally, other than weird situations like that, the fewer parts, the better. Less things had to be cut, less things had to be handled, less things had to be programmed into the CNC machines and so forth. So it's cheaper. The only problem is it's a little on the ugly side. No, it doesn't have to be too terrible because like the STX, I don't know why it's so laggy. If we get a picture, whoops, if we go back to Vivaldi, what's it under? STX, there you are. Okay, so basically like this. So you have like the one piece on top and then the frame section. So it'd be basically this just kind of on its side. So I don't know, that doesn't look too bad. So we'd have like cutouts for the video card vent, and then on the back would be the, or I guess it'd be like the other side here, we'd have the video card. It's not too terribly ugly. And then unlike this, we wouldn't have to have all these like vents and stuff here on the other side. It would just be flat. So that wouldn't look too bad. Yeah, I think it'd be good enough looking. So we could do that. And that'd be relatively simple. So we'd have flanges here and here and here and here for like the exterior panel to screw onto. So wouldn't be the prettiest thing in the world, but it wouldn't be too ugly, and it'd be really simple, so it'd be cheap. Because the thing is, kind of saying, I mean, you're paying $250 for like the Thunder 3 box, and then you're basically throwing away the enclosure for it, and the AC adapter for that matter. Oh yeah, that's why I wanted to do this. I remember now. Yeah, well, real quick though. So yeah, we want to keep the enclosure part cheap because you're buying the Akitio, or however you pronounce that, and then throwing away half of it because you just want the circuit board, and then you need like some kind of power solution and then the video card. So we want to keep the enclosure cheap. So just a simple 2-piece design should be relatively cheap, even in small quantities. So yeah, I think we'll do that. But yeah, as far as the power, I remember now why I needed to do this form factor. It's because I don't know if we have any good pictures of it. The Akitio Thunder 3. The problem is I don't think their website has good pictures of this. There it is. Oh, that's 12 volts. Well, that changes things. Because the board, the Thunderbolt 3 board, uses a DC jack for input power. So that powers the Thunderbolt 3 controller, and then it powers the slot, I believe. So the like the 60 watts or whatever, 60 to 75 watts for the slot power. And then the rest will just come right off the power supply. I thought it was 19 volts, so then we would have had to use I Love Lampshade's custom unit he has coming out from HD Plex. But this is 12 volt, so interesting. So we won't need his custom unit after all. It is just 12 volt. Interesting. I should have checked that beforehand. Let's see. There's not a good picture, I don't think, of the actual DC jack. If it's like a separate section that can be just like tapped into. I think there were some pictures on the other thread. Let me see if I can find it. That's all the stuff we were just looking at. Somewhere in here, there are pictures. I guess basically we're doing this, but a little bit bigger for power. It's kind of funny. Yeah. Wait a minute. Nope, can't see. Oh yeah, there's fan headers. I forgot about that. So you could power those 40 mil fans. Okay, here we go. So it is just a DC jack. So, or at least it's not like a separate daughter board. It's just part of the PCB. So the thing is, what he did is he just soldered onto it for power. So rather than having to plug in a DC jack or a DC connector of any kind, he just soldered straight onto it for the 12 volt and the ground. The problem is like, that's definitely doable. It's a much cleaner solution. I don't think most people will want to do that. They'll just want something plug and play, or at least relatively speaking. So what I was originally thinking we would have to do is we would have to use I Love Lampshade's custom unit, because it would have basically 19 volt pass through from the AC/DC adapter, and then it would have like a little pigtail extension that would plug into that DC jack. But now that we know it's 12 volt, we don't need that. So we would, I guess you'd still end up in the situation where like, how do you connect that DC jack to this? So you would need some kind of like 4-pin to that kind of connector, which that looks like a 5.5 millimeter, just like your standard 5.5 millimeter outer diameter by 2.5 millimeter inner diameter. This makes things more complicated, because it's not too big a deal to wire that up, but it's definitely not something. Whoops, 7-pin. I want a 4-pin. Most people would want to do 2 5.5. Let's see if like something exists already. Okay, I don't know why it does this. Yes, block it. Well, this is kind of stupid, because like this connector is just a little screw in. Like it's not like a permanent connection or anything. You stick the wire in there and screw it down. It's just a screw down terminal. So you basically, I guess you could do that though. It's kind of clunky. I forgot about this part. So this part of it may be a bit of a hack job. And then what I'm thinking we may do in this case then is that, because basically you'd kind of have this hack job for the connector. How do I want to do this? I was thinking we could have the case kind of like come out and cover that, but then you still need access to the video card itself, plus you need access to the Thunderbolt ports. How am I going to do this? And I guess I need to take into account the width of the connectors itself. I forgot about that too. Interesting. That's a bit of a dilemma. Okay. Well, it's 10 o'clock. It's been, what, 2 hours, I think? So I think what I'll do, we're kind of at a standstill. So I guess we need to figure out, I guess we can have some discussion in the forum thread about the power solution, because I'm leaning towards this internal AC/DC, like I said, just for reasons, and then just the HTPlex, like this style form factor. But we could have some discussion about it on the forum thread about which route we want to take for that. And then I think before we go too much further in the frame chassis design is I think I'll have to wait until I have the board and I can figure out how exactly to power the board itself from whatever route we take for the internal unit. And then how, like, I think at this point I'm really going to need better dimensions and measurements of the controller, and then yeah, like the IO ports that are on it, because I just realized from looking at the picture I forgot to take the PCB. I have roughly accurate, but I didn't take into account the connector sticking off of it. So yeah, I think we'll call it quits for today. Okay, Friday. Okay, so Friday, so I probably won't get it till mid next week, which is fine because I have other projects planned, and it'll probably take me a day or two to measure it. So yeah, probably not next Wednesday. So what I may do, oh wait, next week. Okay, because we usually, our normal podcast schedule is every other week, and we're doing CES this week, so next week we don't have a podcast scheduled. So okay, what I may do then is that okay, I think what I'll do, if I get it in time and I have time to measure it, I think we can kind of maybe tentatively plan for me to do another live stream maybe Saturday afternoon. And I think what I'll do is I'll try to do it more like 3 in the afternoon, so that would be Central Time. That way we can maybe hopefully get some of the Europeans in here, because right now it's 10 o'clock here. Europe is about, I know like Germany is about 7 hours ahead of me here. So it's like 5 in the morning in Germany. So like kind of like our regulars like Funks and stuff can't join us because it's like they're asleep right now, like nice people are. So yeah, I think Saturday will, or not this Saturday because we'll be doing CES and all that madness, but next Saturday, so that would be the 14th, January the 14th. I think we'll tentatively plan to do another live stream January the 14th, and I think what it is I should have measurements of the PCB and everything by then, so then we can make a more educated decisions on how exactly the frame and the size and the layout and everything, and we'll have a good discussion about the power solution. And then maybe we'll have something better figured out for the streaming platform. I don't know if we'll use YouTube again. Maybe we will, maybe we won't. I don't know. We'll have to have a good discussion about that too. But anyway, so kind of rambling, aimless nonsense, a lot of wasted time waiting on Space Claim to quit being stupid. But I don't know. I hope this just kind of gives you guys like insight into like kind of the design process. And of course, like, this isn't anywhere near like the best way to do it at all. This is just kind of, this is how I normally work, because I have like really rough stuff and I just kind of throw it together in kind of a rough layout and just kind of start honing it in from there. So, but anyway, so just, I don't know, a little bit rambling, but hopefully kind of insight into the, like, the way I work. So, but yeah, definitely. Yeah, I mean, I don't know. I feel we've made progress, but now it's like, now that I've kind of got into it, now I've realized we have a lot more progress to do. But that's SFF case design for you. You may think it's simple, but it is very much never simple. So anyway, so I'll just leave it at that, and we'll catch up maybe next Saturday, but if not, I'll definitely post in the thread about what time it is. So all right, so I'll sign off, and thanks for joining me.